This is AP Precalculus Notes for topic 3.11, the secant, cosecant, and cotangent functions. Yes, we have three new functions. They're just the inverses, not inverses, they're the reciprocal of our old cosine function. So if you take 1 divided by cosine, if you flip it upside down, you get the secant function. If you do sine and you flip it upside down, it's cosecant, and cotangent is tangent upside down as well. Again, don't accidentally divide by 0. That's never 0. So the way that these are kept straight in my mind, whenever you see an S, remember that there's an S in the middle for cosecant. Secant, again, it's a consonant, vowel, consonant, consonant, vowel, consonant. Hopefully that helps you a little bit. Those two always match with each other. You can always think of this backwards, C and S, C and S. I don't know whatever way that you want to remember that. You need to remember that secant goes with cosine and cosecant goes with sine. Cotangent, I've never had students been able to forget that one. They usually know that one. So what do these functions look like? Interestingly, they have this multiple parabola shapes, and they have a bunch of these vertical asymptotes, and they have a no man's land. You cannot have anything in between this old region where we used to have our function. Our function used to oscillate between 1, this height of 1, and -1, but now this entire range to the left and to the right is no man's land. There is nothing in that area anymore. So where do these vertical asymptotes happen? They happen whenever we cross 0, because you cannot divide by 0. Again, when you take the reciprocal, it is now on the denominator. Don't divide by 0. So I know that one of the things that students usually struggle with is, what is the difference between cosecant and secant? Because they both look the same, except they're just phase shifted to the left and right. Remember that secant comes from cosine, and cosine has this function that goes through 0 at pi over 2. Therefore, we have a vertical tangent at pi, or vertical asymptote at pi over 2 and negative pi over 2, where cosecant has those vertical asymptotes at 0, because sine goes through 0, and then pi, and then 2 pi, and then 3 pi. What's interesting is all of these three new functions, which is secant, cosecant, and cotangent, all have a period of pi. Look at the distance between these. Between pi over 2 and negative pi over 2, that is a total distance of pi. Same thing over here. Total distance of pi, which means out of the 6 trigonometric functions that we know, between sine, cosine, tangent, cosecant, secant, and cotangent, 2 of them have a period of 2 pi, whereas 4 of them have a period of pi, which means if you had to guess pi. It's more likely. Again, you can just memorize this as well, that if you have a secant function, it's pi over 2, and then the period is pi, whereas my cosecant, it has a 0 and then plus pi over k. The range is interesting. I already told you this, but it has a no man's land in the center region, which means it can be everything down from -1. So -1 is right here, and everything down from -1, and everything up from +1. So everything up from +1 for both secant and cosecant. Let's talk about cotangent. So cotangent, again, is a little bit interesting, because normally tangent looks like this. It has a range between negative pi over 2 and pi over 2, and it comes up through 0 like this. But notice now we still have the same period, but I've kind of phase shifted to the right now. So my period is between 0 and pi, so it's still a period of pi, but I've also flipped this as kind of like reflection over the x-axis. So it's now going from the top left to the bottom right, as opposed to the bottom left to the top right. And it's, again, shifted a little bit to the right. So I have vertical asymptotes at 0 and pi. Why? Because I went through 0 again at the origin, which means that needs to be a vertical asymptote. All right, let's move on to an actual problem now. So I have my secant function. Okay, so secant, I remember that C and S comes from COS. So this is the inverse, or not inverse, the reciprocal of cosine. And I need to find its vertical asymptotes. Well, we changed what the period normally is. Normally the period for a secant function is pi, but we have to do this new formula that says period is equal to pi divided by b. And we know what b is. B is 2. It's the number in front of the x. So my period is pi over 2. And again, the way that this works is you kind of go forward half a period and backwards half of a period, which is really similar to the way that we did our tangent function. Our tangent function went forward half period and backwards half period as well. Remember, where does secant have our first vertical asymptote? You can come up here to the next page and say, okay, well, secant normally has vertical asymptotes at negative pi over 2 and pi over 2, because it's forward half a period and backwards half a period. So if I come back to our problem now, if I go forward half of a period, half of pi over 2 is pi over 4, and oh look, pi over 4 is the correct answer, and then you keep repeating that every period. So you can say also plus pi over 2, the period k. But that is just one of the vertical asymptotes. So let's try another one. All right, cosecant. So cosecant, we need to look at the period first, so I can use the same formula. Period is equal to pi divided by b, and in this case, b is pi, so it's pi divided by pi. Therefore, the entire period is 1. So normally, cosecant comes from sine, because I see the s in the center, which means I'm doing sine. Sine has a vertical asymptote at 0, and there's no phase shift, not yet. So that means I have a vertical asymptote at 0, and then I go forward a full period, 1 to the right, and oh look, 1 to the right. The correct answer here is D. Let's try another one. Cosecant. Okay, again, I see the S indicating that this came from sine. Sine normally has a vertical, here, let me draw this out, right? Sine normally looked like this, where it came out from 0, which means if I have the inverse of that, I can't divide by 0, and I have this vertical asymptote right here at 0. I can just do one line, which means I need to, again, look at the period though. So period is equal to pi divided by b. What is b in this case? Well, it's 1/2. So b is going to be 1/2. I'll say this is pi divided by 1/2. I'm going to do a keep, change, flip. So keep it, change it, flip it, and this is going to be 2 pi. So I'm going to move a full, this is 1 full period now. I'm going to move between 0 and pi, but not pi anymore. It's 0 and 2 pi. Oh, wait, it's not even asking about the period anymore. It's talking about the range. Silly, Mr. Sindel. Undo all of that. Normally, we have a function that is in a no man's land between -1 and 1, but we have multiplied everything by 3. 3 is our vertical dilation. We have done this vertical stretch by a factor of 3. So it used to be, this is the old one, but now everything is multiplied by 3, so there we go. 3 times infinity is still infinity. So the correct answer here is C. Number 4 is asking for vertical asymptotes again, so we're going to go back to that one. Cotangent, again, has that feature where we go between, let me draw out tangent really quickly. Normal tangent looks like that, which means whenever we touch this 0, that is turned into a vertical asymptote. So I have my vertical asymptotes here, and I know that the period is always going to be pi, so this comes over here at pi. But again, we've changed the period, so the period is now pi divided by b. B is 2 pi, and the pi's and pi's will cross cancel, leaving behind 1/2. So I'm going to go forward a full period, forward 1/2, and I get my value of 1/2. All right, let's try another. Example 5. We need to, what are we looking for? Points of intersection. Okay, whenever we're looking for points of intersection, we set one function equal to the other. So I'm going to set 4 cosecant of x plus 3 equal to the other function, which is just 11. And we're going to solve this. Okay, so I basically want to get the cosecant by itself. You always want to get your trig function by itself. So the way we do that is to get rid of the 3. We're going to subtract 3. That gives us 4 cosecant of x is equal to 8, and then from there we're going to divide by 4. That gives us cosecant of x is equal to 2. And what is cosecant of x? Well, I know that the s in the center means I have sine. This is 1 over sine, so let's actually write it like that. We'll say this is really 1 over sine of x, and that's equal to 2. So to solve for this, I need to take the reciprocal of the right-hand side, and I need to take the reciprocal of the left-hand side. When I do that, it turns into sine of x on the top, technically over 1, but I'm not going to write that, and that's equal to 1 over 2. And this is that trig function that can be answered with a unit circle. Do I still have... No, I do not have a unit circle. Let's turn that zoom off. I thought I could paste. So if I have a unit circle, please be a circle. Circles are hard. There we go. If I have my unit circle, let me make these lines really nice, and then I can copy and paste this later. Grab all of you, copy for later. Okay, so if I have a sine value, that is talking about a y value. I need a y value of 1/2, which happens right about there, which means I have a point here, I have a point here, and I can have these two solutions, which is 5 pi over 6 and pi over 6. And those are the two solutions. I guess I can just box them, or I can come down here and I can rewrite it, and I can say x could be pi over 6, or it could also be 5 pi over 6. 5 lines or box it. All right, let's try another one. So again, we're looking for points of intersection. I saw that word intersection, so I'm going to set h of x equal to k of x. Let's go. Okay, 3 minus 1/2 secant of x. We have the 1 over cosine function here, and that's going to be equal to the other function, which is 4. Okay, again, we want to isolate this secant function, so I'm going to get rid of this 3 by subtracting 3 on both sides. Subtract 3. I have negative 1/2 secant of x is equal to 1. And now I'm going to get rid of divide by 1/2, and I'm going to multiply both sides by -2. If I multiply that side by -2, I have to multiply the right side by -2, and I'm seeing that the negative and negative will cross cancel, the 2 and 2 will cross cancel, leaving behind just the secant function of x, and that's going to equal -2. And then from there, I need to rewrite. What is secant? Secant, I noticed that it has a middle letter that's a vowel, so cosine, c, and s, right? So it's 1 over cosine of x, actually, and that's going to be equal to -2. And then from there, I need to solve by taking the reciprocal of the left-hand side, which means I take the reciprocal of the right-hand side, and I say this is now cosine of x is equal to 1 over 2, but negative. All right, let's go ahead and look at that unit circle that I can now paste in because I copied it from last time. Cosine is talking about the x-coordinate. How much left or to the right are we moving? I know I said that and wrote it backwards. I'm moving left 1/2. So left 1/2 lives right about there and right about there, which is 2 pi over 3 and 4 pi over 3. Those are our two answers. Let's go ahead and rewrite those. X could be equal to 2 pi over 3 or 4 pi over 3. Both of those are valid solutions. And finally, we have a calculator question, and it's asking for points of intersection where p of x is equal to 2. So I'm just going to set this function equal to 2 because it says I want p of x to be 2, and I also want p of x to be this equation. Set these two equations equal to one another, essentially, and you can solve. I'll show you how to do that on the calculator. So let's go ahead and do a split view, pull up this is a calculator that's similar but not exactly the same. When I go up here to the top left, I'm going to hit y equals, and I'm going to type in my function 3 minus 1.7. Okay, how do you type in cotangent? To type in cotangent, you do, I'll do parentheses here just in case I get messed up, 1 divided by tangent. It's not arctangent. And then I type in my 0.5x minus 1. I end the parentheses for the tangent, and then I end the parentheses for my 1 divided by tangent, making it a cotangent function. So that's my first function. My next function is 2, and I'm going to look at where these two functions intersect each other. The way that we're going to do that is we're going to go to my window, and my window, it kind of tells me what my window should be. My x value should be between 0 and 2 pi, so I'm going to type in 0. My x max, I'm going to type in 2, and then I hit second to the power of, so pi. Mine evaluates as 6.28, but yours will still say 2 pi, I believe. And we don't know what to do for our y values. The thing with doing zoom 0 on this one, where you zoom to scale, is we'll zoom so far out because we have vertical asymptotes, it'll zoom out to infinity. So I know for a fact that 2 needs to be on that graph, so I'm going to change my y min to like -5 and my y max to, I don't know, 5. That should definitely include my height of 2 in there. And then don't hit zoom anything, just hit graph. When I look at that, I see, oh, there's this intersection around 4, 2-ish. The way that we find the exact value of that is we do a calculation. So we're gonna hit second, trace, and that's gonna calculate, and we want to find an intersection. So I can just hit 5 for my intersection. And you need to, so my menus are a little bit different than yours. You should be choosing a function, and you can use the up and down buttons to select which function you wanna select. We only have 2 functions, so you can just hit enter, enter. You don't really have to worry about it. And then you have to do a guess. For my interface, I have to do a left bound, which I'm just gonna say is 3. And my right bound, I'm going to say 5, and it tells me my intersection. So you should be able to guess what yours is, and I can see that my x coordinate on my calculator is telling me x is equal to 4.078. 1, I guess, if I keep going, but usually in AP, we round to just 3 decimal places, and there's our final answer. That does conclude the notes for topic 3.11. There's page 3, there's page 2, there's page 1 that I didn't even really write on. Thanks for watching.